This is Algebra 2 with Trig, working on Unit 2B.4, the composition of polynomials. What we're recognizing here, it's mainly about notation. The math is not very difficult, but the notation is different. The composition of a function g with the function f is f of g of x. Notice that we typically say f of x. But if we have the g of x inside where the x normally would be, this becomes f of g of x. So this is more of a notation issue. What does that mean? This does not mean multiply the f function with the g function. This means plug the g function inside of the f function. So what we're going to do is take the f function and plug the g function inside for the x values. So the f function is 6 times something plus 2. Look at how we set this up. The f function, f of this, so f of is 6 times some amount plus 2 extra. So we're going to plug the 3x plus 5 inside where the x used to be. The f function no longer has that x. We have the parentheses where we plug in the entire g function in place of that x. Then you go back to your normal mathematics where you distribute and add 2. So f of g of x is 18x plus 32. Now notice that if we switch the order and we try g of f of x, that means we're going to take the g function and we're going to plug the f function in its x values. So the g function is 3 times something plus 5. That's what the g function is. So we're going to plug the f in place of the x and distribute. So notice that these two are not identical to each other. F of g of x and g of f of x do not produce the same expression. We can get as creative as we want. We can even try f of x. So we're going to take our f function and we're going to plug 6x plus 2 in for every x value. So the f function is 6 times something plus 2. So we're going to plug the f of x into the f of x. So we're plugging the 6x plus 2 in place of the x. And then we distribute and collect like terms. So f of x is going to be 36x plus 14. Now this is a little bit different. This is g of 4. This has a number in place of that x value. There's actually two methods. Method number 1, we can first figure out what g of 4 equals. g of 4 is going to be the g function plugging in a 4 for the x. So that gives us 12 plus 5, which gives us 17. So g of 4 is 17. Then we're going to take that g of 4 answer, which is 17, and we're going to place it back into the g function. Because this says g of 4. So we figured out g of 4. Now we're going to plug that into the g function. So that's 3 times 17 plus 5. That's 51 plus 5. That's 56. So g of 4 equals 56. We figured it out in that first method. Was to figure out g of 4, then to figure out g of 17. That gave us 56. Method number 2, a different way you could do it. To figure out what g of x is, we're going to take the g function, 3 times something plus 5, and we're going to plug the g function into it, which means when we distribute, we get 9x plus 15 plus 5, which gives us 9x plus 20. Now we're going to figure out what g of 4 is. That's 9 times 4 plus 20, which is 36 plus 20, which is 56. That is not a coincidence. This 56 is the same as that 56. It's done in 2 different methods, 2 different ways, but we got the same answer. You could either figure out what g of 4 was and then plug that into the g function, or you could figure out what g of x was and you could plug the 4 in there. 2 different ways. Next, we're going to purchase some water skis at a price tag of $180. The sports store applies a newspaper coupon of $50 and a 10% store discount. So we have a coupon and we have a discount. We're going to use composition to find the final price of the purchase when the coupon is applied. So what we're going to look at, we're going to say that f of x is going to be your total cost x times 1 minus 10%, which is the same thing as 0.9 times x. So if you get 10% off, you are paying 90% of the cost. If you calculate what 10% is, you then have to subtract it from your total. But if you calculate what 90% is, that's the amount you pay. So it might be helpful to think about 10% off as 90% of what you're paying, because you have 100% minus 10%. G of x, we'll consider this the coupon. This is going to be your total price minus $50. And there's not much of another way to do that. So if we come down here, we're going to use composition to find the final price of the purchase when the coupon is applied. The coupon, remember, was the $50 off. When the coupon is applied before the discount. So what we're doing is f of g of x we're going to do the coupon, the g of x first, and then we're going to do the 10%, which is the discount. So if we know our price is $180, g of x is $180 minus the 50, which gives us $130. And then you plug that $130 into the f function. The f function for 130 now is going to be 130 times 0.9. We are getting a 10% discount, which means that we are going to pay 90% of the cost. So you can do 130 times 0.9, that's $117. That's how much you would pay. If you got your 150 off, actually you got your 50 off, and then you pay 90% of the total cost. Notice that that would be the same thing as your 130 times 10%, which is $13, and you get $13 off of your 130. It's still 117. Okay, use composition to find the final price of the purchase when the discount is applied before the coupon. The discount was the 10%. So this time, this is going to be g of f of x. So the f function, when that's 180, when your price is 180, you're going to do 180 times 0.9. Well, 10% of 180 is 18, and if we take that off of that, that's going to be 162. So then with the g function, we take the 162 and we subtract the 50 from it, and that gives us a total price of $112. So we notice that the B situation is a better sale price compared to the A. Not by a ton, but our numbers aren't super big, so it's still $5. One of the questions might be, why is it a better deal? What was the mathematical calculation that was done? If you notice, we took a percentage off. We took 10% off of the 130. Here we took 10% off of the 180. We paid 90% of the 180. That was a bigger amount off than it was here. Here this took off $13. Here this took off $18. We always took off 50, but we got to take off a larger amount in this situation than we did in this one because we applied it to a smaller number. So on our next page, it's just more practice problems, very similar to the homework. So we're looking at f of g of x. We take our f function and we're going to plug the g function in its spot. So that means the f function is 5 times something minus 4. This is going to be 5 times x cubed minus 4, which is known as 5x cubed minus 4. this is g of f of x. So we take the g function and we're going to plug the f function in its spot. So the g function is something that's being cubed. So this is 5x minus 4 that's being cubed. Well, we don't have a way to cube that without doing it the long way. We could use the binomial theorem, but with a cube, it's not all that much more difficult just to multiply it out. So here we're going to get 25x squared. 20 and 20 gives you negative 40x plus 16. That gives us that times 5x minus 4. So we get 125x cubed minus 200x plus 80x. Then you multiply it all by the negative 4. So negative 4, this would be squared, by the way. Negative 4 times 25 would give you a negative 100x squared. And negative 4 times 40 would give you a positive 660x. And negative 4 times 16 would give you a negative 64. So if you group those together, it looks like we get 125x cubed minus 300x squared plus 240x minus 64. A little crazy looking, but the process was just g of f of x. We had to cube the f of x. So the f function, and we're going to plug the h function into it. The f function is 5 times some amount. So that amount is going to be our h value. And we minus 4 from that. So we have to distribute 5x cubed minus 10x plus 35 minus 4 more. 5x squared minus 10x plus 31. That's going to be your f of h of x. Now to watch something different, this one is different. So pay close attention to what we're doing here. This is h of f of x. So this is taking your h function and plugging your f function in its place. Well, the h function is a term that's being squared minus 2 times that same term plus 7. So we're going to plug our 5x minus 4 inside of that. I'm just writing it in a new line so you can see that there's a different thought process. Minus 2 times 5x minus 4 plus 7. I plugged the 5x minus 4 in place of the x that was part of the h function. Now we have to square. When you square a binomial, there is a shortcut to it, remember. You can square the first term, you can multiply the two together and double it, and then you can square the last term. So we get 25x squared minus 20 times 2 is 40x and 16. Then distribute through to get negative 10x plus 8 plus 7. So that gives us 25x squared, negative 50x, 16 and 15 is 31. So that is going to be h of f of x. Down here we are evaluating. This is a g of f of 2. I'll do one in each method. So here I'm going to figure out what is f of 2. The f function is 5 times something minus 4. We're going to plug the 2 in place of that x. So that is 10 minus 4, which is 6. Then we're going to take the g function and plug the 6 in its place. So the g function is just something being cubed. So we have 6 being cubed, which is 216. So g of f of 2 is going to be 216. The other method that we talked about was to first figure out what is f of h of x. Well, we take the f function, which is 5 times something minus 4, and we're going to plug the h function in its place, which is x squared minus 2x plus 7. I'm just writing it as a separate line so that you see that it's almost a separate thought. So we get 5x squared minus 10x plus 35 minus 4 more. So those were two different methods. Oh, okay, so I figured out what f of h of x was. Now I have to figure out when I plug in 2. So this is 5 times 2 squared minus 10 times 2 plus 31. 4 times 5 is 20 minus 20. Did I do that right? 4 times 5 is 20. Minus 20 plus 31. I messed up somewhere. Nope, didn't mess up anywhere. These are not the same problems. They're not going to get the same answer. So this is going to come out to be 31. What we've noticed so far is that f of g of x and g of f of x are not the same. So composition is not commutative. Multiplication is 2 times 3 and 3 times 2. You can switch those. Addition is 5 plus 4 and 4 plus 5 give you the same answer. But subtraction is an example of not being commutative, because you can't switch in a subtraction problem. You can't do it with composition either. All right, jumping back up to here, we were supposed to plug a 1 in for this problem, not a 2 in for this problem. A 2 was this one. That's what was getting me a little bit confused there a moment ago. So this is 1 squared, which is 1 times 5. Minus 10 is negative 5. So this should be 26.